In this video, I am going to walk through the Module 3 assignment and how to answer the questions and some tips in Excel. The first thing we need to do is find the regression equation. And it gives you a little tip here. You can use the scatter plot from your Module 2 assignment. So get into Excel. You should have a sample of size 30 from Module 2. And we really just need the median square footage. That's our X variable. So I'm going to list that first, and I'm going to take the listing price, my response variable Y, and list that second. I can kind of ignore all the rest of this over here. I have my X, explanatory predictor variable first, my response variable second. And that's important to have the right predictor variable. I'm here in the guidelines and rubrics. We want to be using the square footage of a house to predict what the price should be for that house. So the X predictor needs to be the square footage. So if we just select this data, I'm going to drag down with my mouse, make sure I got all of it, insert, scatter plot. We have it. You want to change your chart title, verify that your square footage is your X, prices are your Y. Right click on any one of these data points and go add Trendline. And off to the side of Excel, a little window pops up. You can display the R squared value and display the equation right there on your chart. Click those two boxes, and then we're going to go back to our chart, and I'll try to make it a little bigger here. Well, I think I can select that maybe, and there we go, up the size. I'm just clicking to make it a little larger to make it easier to see there. All right. So that equation you'll want to list here, and you can use that equation now to make predictions. If you know the square footage of a home, you plug that in for X and then calculate it, and it gives you a prediction of what Y, the cost of that home, should be. The next thing you want to do is determine R, which is the correlation coefficient. And you can see we have R squared listed right here. So in Excel or on any calculator, a very quick way to get R would be to take the square root in Excel is equals SQRT, and then just type in that number. And so if you're taking the square root of the thing squared, now the result here is just what R is. So 0.8356. In 3.3 in Zybooks, we learn how to interpret the correlation coefficient. And this value of R is always between a -1 and a +1. It's somewhere in there. The closer it gets to the ends, to either a +1 or -1, the closer we have to perfect linear correlation where all the points in our scatter plot would be on a straight line. So this table is very useful. We got some pictures that can help out here as well. These points are all really pretty close to the line. So you see our R value is at 0.9, which is in that strong correlation range in between 0.8 and 1. And here we have a negative sloping, so you see R is negative if the trend line is going down, and the points are more spread out. And so -0.7 falls in between, its absolute value is in between 0.4 and 0.8. So we'd have moderate correlation, and it's negative here. The line goes down and R is down, and R is negative. So see what your R is. Mine fell within the strong correlation between 0.8 and 1, and it's a positive number, so I have a positive upward trending linear correlation. And just discuss that a little bit, reference that chart, reference the absolute value of R and what you can learn from that. So now examining the slope and the intercepts. The y-intercept's probably the most useful here, just because that would be when X is 0, when X is our square footage of our home. And so if X is 0, that means there's no house at all, and we're just looking at the land then, the value of the land. All right, so a y-intercept gives away the value of the land. If you actually look at the equation I have for my data, if I plug a 0 in there for X to find the y-intercept, I'm getting a negative value of the land. So that tells me, and that could be your case, if that's the case, this chart is not, or this regression equation is not useful outside the scope of the data, and we should not interpret the y-intercept. It doesn't make sense to have a negative land value if there's no home on it. Some of your samples might have a value that does make sense. You plug a 0 in there for x, you find the y-intercept, and it could be a positive value, and you would interpret that then as a 0 square foot house, which means there's no home. The land is still worth whatever value the y-intercept has. In this scenario, we don't want to, and this is often the case in correlations, it's dangerous to project outside of your data, and a square footage of 0 is way outside of our data because our data starts up here for houses around 1500, and so our line does not project well for when there's no home. So we would not use this to predict the value of the land. Now, as far as the slope always tells you how much y increases for every 1 increase in x. That's for any line ever. That's what the slope's telling you. If x goes up by 1, how much does y go up by? So in the context of what we have in this problem, as the square footage goes up by 1 square foot, the house costs an extra $306, roughly. So if you were a realtor and you said, oh, this house over here is 100 square feet bigger, you would say it probably costs $30,000 more dollars. So 306 times 100 more square feet, going up by 100 times that, you would get 30,000. So that's how you can use the slope and interpret that in this problem. For every 1 square foot increase, that's how much the price of the home is predicted to go up by. Now the next thing we want to look at is the r-squared coefficient. And remember, that's shown up right here on your graph. We got 0.6982. And to learn more about r-squared, the coefficient of determination, again 3.3 in the Xi books, it gives the ratio of the variance in the response variable, which in our case is the price of the home, explained by the predictor variable, which in our case is the square footage of the home. And you can read a little bit more about that, but it's basically going to follow the same pattern where the closer r-squared is to 1, the stronger, it's written down here good. And r-squared of 1 means that all of the variance in your y, your response variable, in our case, price of the home, and r-squared of 1 means all of that change is explained by the predictor variable, the square footage of the home. So the further you're getting away from 1, the less of the change in home prices is being driven by square footage alone. And if it's all the way at 0, it means none of the change in home prices is explained by square footage, your predictor variable. And finally, just reflect back on everything you did here, all the data you gathered, and just present it, kind of the highlights that you pick out from there. If you had to give a 30-second minute pitch to your boss, if you work at a real estate company, about what you learned about the relationship between square footage and home price for that region that you picked, what would you say in that 30 seconds, that minute? And you write out several sentences here, talk about all the different things in here, everything we covered, refer back to the regression equation. How can you use that to plug in values for square footage and calculate an estimate for the home price? And do you think that would be a good estimate based on R and your r-squared, or are those values saying there's not that strong of a relationship between square footage? Maybe home prices in your area are driven by something other than square footage, location or age of the home, or something else that drives home prices. Reflect back, give a brief interpretation of what you learned about the slope and the y-intercept, the value of the land. Were you able to determine that or not? Reflect back on the whole entire national market. If you can make some comparisons between your region and that would be good as well. But just reflect, hit the highlights, reference your data, and bring in some statistics here. So let me know if you have questions about any part of this assignment. I'll be happy to help more if I can. Reach out and have a good rest of your week.